Let me explain the structure of a static RAM. Here you can observe in this section you have got PMOS at the top and NMOS at the bottom. PMOS is connected to the VDD and NMOS is connected to the ground. Here also you have got PMOS and NMOS combination, wherein PMOS is connected to VDD and NMOS is connected to the ground again. So here the PMOS and NMOS together work as an inverter, and also here the PMOS and NMOS similarly connected will also work as an inverter. As you can observe, output of one inverter is connected to the input of the first inverter. Like that, output of the first inverter is connected to the input of the second inverter, so that the two inverters are coupled to each other between their inputs and outputs. If you couple back the output to the input of each other inverter, you have constructed a flip-flop. So PMOS, NMOS together they form a flip-flop. And then output of one combination of PMOS and NMOS is called as Q bar. The other combination is called as Q, which are read to the bit line on either side through a pair of transistor. So this transistor is enabled by WL, and this transistor is also enabled by WL. So these two transistors will enable us to read or write onto the flip-flop. So this WL likewise can enable 8 this sort of cells in a row together to access entire memory location. So herein, by using 6 transistors in all, you have constructed a static RAM. So this static RAM stores the information in the form of voltage. Voltage will not be lost quickly. Therefore, it is called as static RAM, because information is stored in the form of voltage. But the disadvantage is you need 6 transistors in all to construct one flip-flop cell. Thereby you are occupying more space and it will be more expensive. That is the disadvantage. But the advantage is you need not refresh the memory continuously, because it will be storing the information in the form of voltage. Hence it is called as the static RAM.